Great. So thanks everyone for attending the August open planning meeting for Deis. This is our third planning meeting, public planning meeting, and we're using Zoom this time around because, for the second time, because it seems to be the lesser of evils between Google Hangouts and Zoom. Zoom has a lot more participants it can handle. So unless folks have some problems with Zoom, we're going to continue using this. So I don't expect the meeting will take extremely long today, but I do want to start out with just kind of the rough agenda. So first, Chris Armstrong, the Deis team lead, is going to give us a run through of what happened in the v1.10 release. Then we're going to move on to talking about what's on the existing roadmap, how that's changed in relation to what we've accomplished in the 1.9 release. After that, we're going to talk about some new additions to the roadmap that we've had from talking with some users and some customers. And then at the end of that, we're going to open it up to just general Q&A from the community. So that said, though we're doing Q&A at the end, if there are any questions while we're talking about stuff, please feel free to jump in and ask something. So with that, I'm going to go ahead and hand it off to Chris.
Thank you. Good morning, everybody. Thank you for attending. Just want to talk briefly about Deis 1.9. I'm looking at a release notes now. This release saw a kind of a culmination of a lot of work from our interns. If you guys have seen Kirtan Malla and Joshua Anderson. Josh has been on the project for about a year, but we hired him for a summer internship. And they did a lot of the work that you're seeing here. Specifically, Joshua has rewritten the Deis client in Go. It's not been taken over as our main client yet, but it's in the client Go subdirectory. We encourage everyone to try that out. Our current client is a Python client. The idea is that the UX is the same, so you won't notice a difference, except it'll be faster and more portable. So we want to try to get that merged here soon. So if you have any interest, vested interest in playing with that, please do so soon and give us your feedback on that. And then also this release saw the shipping of the Kubernetes and Mesos application previews. If you'll recall, we shipped Docker Swarm preview, I think a release or two ago at this point. The idea being that we understand that a lot of our users already are evaluating other application schedulers besides Fleet. They either already have clusters up, they have test clusters up, they're evaluating these other clusters, these other scheduling clusters. So we now have support. Deis can schedule applications to Kubernetes or Mesos clusters. There's great documentation around that. A lot of the Mesos work was Kirtan on our team, the Mesos work was Sivaram, and the Kubernetes work was Kirtan. So if you see them, say hi. They're around. Two other big things to call out for this release. One is application health checks. This is something that people have been asking for a long time. We're sorry it took so long to get to you. The idea being, currently the way application deploys work on Deis is that when you ship a new release, we start the new containers. And as soon as the containers report that they're up and running, Fleet says, hey, these guys are running. We then coalesce your old containers. So as soon as the new release is running, we kill the old release. However, for a lot of people, obviously, the real-world applications don't start up instantaneously. And we were killing the old containers before the new ones were actually serving traffic. So Matt Fisher, if you want to talk briefly about kind of how we solved that problem for this release.
Yeah. So I'm Matt Fisher, Bacon Gobbler on GitHub and all that. For the health checks, it's at most of what you would expect. It does after we've deployed it for the same way that, for background on how, like what Chris said, that they used to do a lazy check on if the containers were up and running, and if they are up and running, they'd just be deployed and the old ones would be recycled out, and that's pretty quick and easy. But with the health checks, what I'll do is there's two different things that happen in a health check. Two things that people are concerned with. One is initially when container comes up, is it alive and is it ready and is it responding healthily, or is it dying, flapping, or is it not just working at all? And the other way that a health check works is it actually up and running after a certain couple of months? Is it still serving traffic? Has it still not gotten underloaded? Is it not dead yet? So those are the two things that I addressed. And one of them, for the first one, was the readiness check, or which is basically, is the container ready to run? And that just does a basic health check against the new application container. And if it's okay, then it will deploy the new container and recycle the old one. However, if it doesn't pass, then it'll do a back off interval delay to basically every X seconds you set. It will do another health check another 3 or 4 times just to make sure, okay, is it up, is it up, is it up? If not, then it completely says, okay, this application is not good. And then it does the old, well, application never failed to come up. And then as for the liveness checks, which is on publisher's side, publisher is a sidecar container that actually runs on one of the hosts on the data plane itself, and it actually publishes the containers that are running through your application to etcd. Along with that, it also checks that the container is up and that it's responding correctly. With the new health check, it also, if your application set the health check feature on, it'll also perform a health check and make sure that it is okay before it publishes to etcd. What this means is that because the router relies on etcd to publish the containers, if the publisher does not publish that container to etcd, then the container never gets added into the router mesh, and so the container is never put in there. So if you have one container that doesn't work, but 3 others do, then the 3 will still be in Nginx, but the 1 won't. So that's the health check feature.
Thanks, Fisher. Yeah, so to recap, we're health checking both at the deploy level and at the routing level before we publish application containers to the routing mesh. Documentation for health checks is in the Deis documentation under using Deis, a subsection called configure an application. So there are actually 3 different variables there that you can set to configure health checks. So encourage everyone to take a look. So that's one big feature. The other one I want to touch on briefly is graceful upgrades. One thing that people, upgrades currently are a pain point for people, right? Currently, the documentation to do a Deis upgrade, it's either an in-place upgrade or a cutover upgrade, both of which are painful for different reasons. One incurs downtime. The in-place upgrade incurs downtime, but it's easier. And then cutting over to a new release of Deis requires you to deploy a second cluster in parallel. Ian Coffey did a lot of work. One of the things in our roadmap you'll notice is the update service. And the first half of the update service is an update client that has logic around how to do a graceful upgrade. So we kind of split the work up into 2 phases. The first phase is the client deploy. So Ian released Deis CTL support for upgrades this release. I'd like to have him talk briefly about that. Ian, are you on?
I sure am. Yeah. Do I also sound like garbage? Or is it just Chris? I guess we'll
No, it's crystal clear on your end. I think, Chris, you got a little bit of static on your microphone, but you're good otherwise.
All right, let me see what I can do about that. Thanks.
I'm working with low bandwidth, so if I freeze or turn robotic, sorry. But yeah, the update logic is essentially just 2 steps. Assuming you're coming from like you're going from version 1 to version 2, you'd be able to use the version 1 client and run something called upgrade prep. And what that'll do is that'll take down your platform, saving for the things that are necessary for continuing to serve traffic to your services. So that would be the publisher and the routing mesh itself. You can leave that running indefinitely. There's no time limit. You're not going to run out of space or time there. You don't have to rush. But once you have a new client installed, you could then run takeover. And what that will do is it'll take down first it'll set a longer TTL for the published services so that they don't time out quite as quickly. Right now it's 20 minutes. Takes longer than that, you might run into trouble. So maybe something to improve in the future if it ever breaks down the publishers and then does a routing, a rolling restart of the routers. Once those are up, you're in the clear, and the rest of the new platform will come up. And following that, you just plop your new DSCTL binary of the old one, and you should be done. So they're really, it's kind of load balancer specific if you're going to see a moment or 2 of downtime. But if you're not terribly pessimistic on adding members back into your LB queue, you probably won't see any downtime. And that's it.
Awesome. Thank you, Ian. I don't know if I sound any better now. I've switched headsets. So that's basically the 1.9 release. We had health checks, graceful upgrades, Bezos, and Kubernetes previews. That's the release. So with that, I think, does anyone have any questions on anything we shipped in that?
Yes, we should mention flannel as well.
That's right. Kent, do you want to talk a little bit about the overlay PR?
Actually, guys, we're going to go through the details of what was shipped as part of the existing roadmap as we check stuff off. So we'll cover flannel and etcd2 and some other stuff.
Okay, we can move on to that now. If anyone has any questions about 1.9. Cool. All right, Gabe, do you want to move into the roadmap?
All right. So yeah, let's jump over to the roadmap. So for those of you who don't have it up, if you go to docs.deis.io, in the right-hand nav bar, click on the roadmap drop down, and then Deis roadmap. And this is kind of what we're gonna walk through. So starting at the top here, we have the TTY broker, and I'm very aware that the TTY broker is actually got a question from Roger about a stateless platform on v1.9. Stateless platform was shipped in v1.8 and should work just fine, same way on v1.9. So really no difference there. With regard to the TTY broker, we realize this is an important feature for folks. One of the things that we've noticed is that depending on which way we go from Fleet, for sort of the next scheduling and orchestration system, the way we do interactive, sessions into one-off containers is going to be dramatically different. So, for example, in Kubernetes, they've already written the equivalent of a TTY broker. It's already merged in the project. With Mesos, it looks slightly different. And so, we're sort of forced at this point to wait and see where things shake out with regard to what the recommended replacement for Fleet is going forward. I expect that decision will be made rather soon. So we're all just going to have to sit tight. We all want the TTY broker feature and interactive Deis run, live log tailing, things like that. We all want that as badly as everyone else. It's just we need to make sure that we're doing this in a way that's going to be the best solution 12 months out. So that's TTY broker. With regard to the next item, scheduling and orchestration, I'm proud to say that we've actually shipped the tech previews now 1.9 for everything that we view as sort of a serious production capable solution that is also resource aware. And just to go back for context, really the reason why we're having to move away from Fleet is that Fleet is not a resource aware scheduler, and it is not going to be a resource aware scheduler. So we're going to have to figure out, from one of these three. And, just to give you a little bit of context as to how this has gone, we've had, some struggles with Swarm. I'm happy to talk, separately about that. But, between, Swarm being what I'll call a little early and a little rough around the edges, and Mesos being a little bit overkill and also really requiring a custom framework in order for it to work correctly with Deis. Kubernetes has really shaken out as the most natural fit, and also something that's working quite well for some of our more intrepid and ambitious users. In fact, Kubernetes, Deis plus Kubernetes is already serving production traffic today. We're seeing that as a likely path forward for our recommended scheduler and sort of Fleet replacement. Moving on, etcd2, I'd actually like for Matt Boersma to talk a little bit about etcd2, and then also Matt, if you could talk a little bit about the overlay networking as well.
Sure. Everybody hear me okay? Yeah. So I'm Matt Boersma. I'm the core maintainer on the project, if you don't know, and you won't be surprised that I'm mostly taking credit for other people's work here. So Manuel did a lot of work on etcd2. So etcd is the core or a core component of the system. We've had some communication issues and problems with the 049, and we've been told repeatedly, you know, we've rewritten the entire thing. etcd2 is coming. That's what you guys should be using. So we finally are. We've seen that, you know, unlike etcd049, when you lose a leader, it can actually reestablish lost leader and recover from that, whereas the previous version really couldn't. So that's great. We did something either stupid or clever, which is in order to make so the trick here is etcd2, etcd1 are not perfectly compatible. So what happens now, if you provision a new cluster on Deis 1.9, you'll be using our new user data, you get etcd2 running, everything will be fine. If you upgrade from a previous cluster, you're still using etcd1, everything will be fine. They advertise the same ports and they actually are functionally the same. But we didn't provide an explicit upgrade path because it didn't seem necessary. Things will keep working. But if you really need to get on etcd2, and the specific reason you would right now is you want to use the Kubernetes preview, you have to provision a new cluster. Because it all boils down to things in user data, which, as you probably know, there's no soft way to upgrade that. So we're running etcd2 in a container, which enables us to be free of the version that's shipped with CoreOS itself, since we're a little back rev with CoreOS right now. We're also running it as etcd.service and masking etcd2.service. The plan here is when we have a big, you know, Deis 2.0 or whatever, where we have to make some breaking changes, we'll probably just start using etcd2.service and throw away the container stuff we've been doing. So etcd2 is there, should be better. Similarly for Flannel, Kirthan and also Kent took a stab at this and got it working. And basically, once again, we need an overlay network. We're going to use Flannel from CoreOS to support Kubernetes scheduling especially. And once again, these are changes in user data. So if you provision a new cluster, you'll get Flannel running. It doesn't really affect the other components other than Kubernetes. If you upgrade from a previous cluster, you won't get Flannel because it's all from the user data, but it doesn't really matter unless you need to use Kubernetes for now. Any questions about that?
Hey Matt, some credit to, or most credit to Manuel on that actually as well.
Oh yes, on the Flannel, yeah. So really Manuel's not in the meeting here, but he did all the hard work and then we just came in and merged his PRs.
Great. Thanks, Matt. So moving on to the next item in the list, you know, there's been a lot of, you know, effort on our end to, you know, try and get a better story regarding monitoring and telemetry. I think, you know, today, you know, most folks who are running Deis are kind of rolling their own solutions. And, you know, really we view it as our goal to provide some standard interfaces as well as, you know, provide things like annotations, you know, on different events in the platform, as well as potentially provide, you know, a way to better aggregate and ship metric data off the platform. So I'd love to have Jonathan Chauncey to talk a little bit more about where we currently are, what we're currently doing on that.
Hi, so I'm Jonathan Chauncey. Everybody calls me Chauncey. I'm new to the team. I've been here about 3 weeks. So I was brought in to help establish kind of the metrics and telemetry system for Deis. So the last 3 weeks have been kind of spent getting my head wrapped around all the different components and kind of what data they need to emit, what data they already are pushing out through either logs or things like that. So I have a open issue design doc for doing metrics and telemetry where I'm kind of documenting like some requirements, some basic requirements, and then also like the current proposal that I have that I've kind of been working on. And so I really want to talk about the piece that is really that's core to this is we want to flow all the data through a stream processor. So we want to kind of minimize the number of components needed to get data out of the cluster and into other systems, right? So we want to be able to, you know, hook up into existing Nagios or PagerDuty, VictorOps for alerting. We want to be able to hook up into, you know, your own time series databases if possible. If you have an InfluxDB cluster or you have, you know, Ganglia or Graphite or something, we'd like to be able to just take all that data and just ship it to whatever you have if possible. makes Deis kind of lightweight, and it allows us to still and Vagrant and things like that and get data out. So what I've been playing with lately is a stream processor called Riemann. It's an open source project. It's written in Kosher. It's pretty rock solid. There's a ton of tutorials and blog posts about it. James Turnbull has been writing blog posts for, I think, the last 6 months about it. So in instrumenting of the Deis system, I actually finished up yesterday instrumenting the router mesh. So just kind of playing with getting logs out of Nginx and doing things with them. So I can capture things like the request per second per service, the request per second on aggregate for the router mesh, the response times, the error codes coming to the system for the responses. And that way we can take all that data and you can write rules about it. So you could say, if I see a 95th percentile response time above 400 milliseconds, send an alert. And since we're gathering all that data across the entire router mesh and processing it in one place, we can craft really some really neat rules and do some sophisticated alerting and graphing on that. So that's kind of where I've been the last couple of weeks, and I'm hoping we can get some community involvement and kind of what people would like to see and what they're expecting out of the cluster.
Great. Thanks, Jonathan. Yeah, and I second that. You know, right now we've been kind of in prototyping mode, and I think it feels like we're starting to exit that mode, and now feels like the right time to start doing a little bit more of this in public and starting to get some community feedback, because I know a lot of folks in the community have strong opinions about how this should be done and what types of systems we want to integrate with, and we want to make sure that all those requirements are being met. So keep posted on the GitHub issues for that, and you can see 3699 looks like the issue where we're currently tracking that. So from here, I'd like to talk a little bit, or I'd like to have Kent talk a little bit about what we're doing on production hardening.
Yeah, so really what this is really about is running larger clusters, which was somewhat of a difficult thing to do before. Anybody who's looked at the different cluster topologies that are possible with CoreOS and etcd and Fleet probably knows that they recommend that you run etcd on a small fixed number of nodes and not actually run it everywhere. The more etcd nodes you have running, the longer it takes for their Raft algorithm to get consensus on things like rights and leader election. So there was a PR that I had opened quite a while ago. It was open for quite a while, that made a lot of code changes to try to make it possible to achieve that better topology where etcd actually runs on a small fixed number of nodes instead of running everywhere. That's back when we were using etcd 0.4.6, but as of 0.5, they added in something called, they added in a proxy for etcd. So what you can do is you can actually run the proxy everywhere except for a small fixed number of nodes. So if you have a small fixed number of nodes actually running etcd, you can have a larger pool, possibly elastic pool, of worker nodes that are just running an etcd proxy. And the benefit that allows is it allows anybody who needs to talk to etcd to simply talk to localhost, and that proxy knows how to sort out who else it's supposed to talk to. Since we've now upgraded to etcd2, we basically got that feature for free, and a lot of the code that I had written just wasn't needed anymore. So we added some documentation updates to how people can modify their user data to make this possible, and that was pretty much that. The other thing that people may want to do when running larger clusters is isolate the control plane from the data plane. So there was some work that we did for that. It had the potential to be a breaking change. So what we did was we made it an opt-in. And I'm happy to say that after a couple months of being open, we just actually merged that like within the last half hour. So that's something that you can opt into now. The documentation is out there.
Fantastic. Very excited to see large scale, cluster, best practices out there. And one of the things I'd really like to see, and something frankly I've heard from a lot of other folks I'm talking to, is some documentation around best practices with regard to cluster topologies. So very excited to see this work really laying the foundation for, some different, types of topologies, including things like geo-replicated Deis clusters, which is something that we have a lot of interest in as well. So yeah, great. Thanks for that. Moving back to the roadmap, just quickly on the stateless logger. So we shipped the optional Ceph and sort of the stateless, not stateless, but the Amazon-backed option for running a Deis platform. The one thing that we missed inside of that was the ability to retain a story for developers running Deis logs and seeing the ability to view most recent logs. Now, in most environments, folks are going to be draining log data out to some log aggregator and have some querying system for that. However, it's still critically important for in a kind of the idea of developer self-service, which is really what Deis is all about, to provide developers with access to recent logs. And so by having a logger component that actually stores in an in-memory ring buffer the last 2 gigabytes or whatever of log data across the cluster allows folks to use Deis logs without incurring a lot of storage overhead. Because all the storage is all done in memory. So we were fortunate enough one morning to wake up to a pull request from a new contributor with a really solid implementation of a stateless logger with an in-memory ring buffer. This pull request is 4083. It looks very close to getting merged, and I would expect this to land in 1.10, but we'll see about that. Moving along to the update service, as Ian mentioned before, this is really something that is going to be staged. We have now some good client inside of DeisCTL, good way to gracefully update an individual node. The end goal here is for Deis clusters to be able to subscribe to a channel, much like with CoreOS, and have, with strong, guarantees of reliability, be able to do automated zero downtime updates of the platform itself. Now, there's a lot to do from where we are today to this sort of dream scenario. This is not something that we're going to turn on folks, without their flipping the switch for this. But we want to get to a point where updates are completely automated, and we're doing a staged approach with how to do this. So if you have any questions about this, Ian is definitely working on some of these components. Moving on to Deis push. For those of you who are familiar with Deis pull, for the Docker image-based workflow, you'll know that we have issues around authentication. And if you can only really pull from your own registry, which doesn't have auth around it, by moving to a model where you actually push into the registry, we can do some pretty neat things with regard to auth. Now, we want to make sure that we're doing this in a forward compatible way, and that sort of means that we need for the Docker registry v2 APIs to shake out, and we've had quite a bit of trouble with the registry v2 implementation so far. So this is kind of on hold pending some stability improvements upstream with the registry v2. Now, we talked about networking v2, and the last thing I wanted to touch on was the service broker. So many folks are interested in, getting Deis add-ons stories so that it's easier to connect to things like backing services. Now, this is another area, much like TTY broker, where depending on where we go with the scheduling and orchestration bit, that will dramatically impact how services get provisioned and how we do things like explicit bindings, ideally with network security and things like that attached to it. I still, right now, believe that the Cloud Foundry Service Broker API is the best implementation of explicit binding. across services. I'm open to other ideas and definitely comment on the issue there, 231, if you have another option for that. But sort of what we're thinking is that the provisioning portions of the Service Broker API would, in theory, allow you to spin up a best practice Postgres database, and then the bind and unbind would be to slice off multi-tenant chunks of that and do automatic attachment of environment variables. This combined with things like software-defined networking additions to restrict and basically open up ports between services and applications, should produce a very robust solution over time. So this is definitely on our roadmap going forward. And at the pace at which we're moving, I expect we'll get to that sooner rather than later. So that is it for the existing roadmap. I'd like to move on quickly to just two roadmap additions, things that are going to be added. First, with regard to the existing roadmap, there's going to be a few things that we're going to knock off of the roadmap because they're done. The first is scheduling and orchestration previews. So those are done. We are actually going to replace that with the new default scheduler. And so we're going to be doing some work to see what the community has to say about what's working and really move towards making a new default scheduler. I mean, I could say Kubernetes is kind of the front runner right now, but the decision is by no means done. etcd2 has been completed, so that will be removed from the roadmap, as well as networking v2, or at least the overlay networking portion of networking v2. So I believe we may drop networking v2 and instead replace it with internal service discovery, which is something we still want, a DNS-based service discovery inside the platform. Okay, moving on to roadmap additions. There are one thing that we've been hearing a lot of from folks is the ability to do teams as well as finer grained permissions. Right now the permissions model inside of Deis is fairly naive. It's really modeled after how Heroku does permissions. So you can add individual users to a Deis application and you can take them off. And then we have a concept of an admin user who's kind of like a super user on the platform. And that was kind of the simplest approach to permissioning. Now that Deis is in some larger environments, folks are interested in allowing folks to see platforms but not push to them or not make config changes and things like that. And so adding finer grained permissions is very important, and as well as adding the concept of teams. So there are two proposals open. The first is 4173 for teams. And you can encourage you to comment on the user experience that we'd like to have there. And then the second is 4150, which is fine-grained permissions. So this is how we would be changing the permissioning system. And so there's quite a deep discussion about both of these going on, and encourage you to participate. But those will be added to the roadmap. And I already mentioned the default scheduler. So that is it for roadmap additions. So before we move on to open Q&A from folks on the call, any questions about what we talked about with regard to the roadmap, additions, deletions, anything else you think we're missing? And let's see, question from JG Mize about fine-grained scheduling policy. Josh, you want to take explain a little bit more about what the intended use case is here?
Yeah. Can you hear me? Okay.
Yep.
Yeah. So I'm not sure if it necessarily is as important with the new default scheduler, being able to handle things better, obviously, than Fleet. One of the main reasons it hasn't been prioritized is because it's really a workaround for some limitations of Fleet. But the ability to, for example, say I want a container to be on every node, or to at least not have more than one on the same node, to be able to spread things out, would be nice. I'm not sure how well, if that's easy to do with Kubernetes, if it does that pretty well by default, or if there's something we need to specifically do to say, I have this service, I want it to be as spread out and resilient as possible.
That's a great question. I was under the impression that with specifically with regard to Kubernetes, that Kubernetes does soft anti-affinity for services or pods that are attached to a service. I've gotten some conflicting information on that, but I know it's certainly possible with a more robust scheduler like Kubernetes. So I do think that the idea of, and Josh, it sounds like soft anti-affinity, meaning that you have HA for
Right.
containers is really the end goal here. I see that as one of the overriding design concerns for this. So we're definitely going to make sure that whatever the new default scheduler, that's that along with reliability and everything else that goes along with it is going to be one of the top concerns. So, but yeah, we should continue to work off this 3289 issue for discussion there. And it looks like we had a chat question. So are there any vague plans for Kubernetes pod style applications? So I'm not quite sure what is meant by pod style applications. Are we talking about co-located containers, or are we talking about, yes, co-located. Okay. So, I think that, one of the things that is going to be important going forward is for us to expose the entire breadth or a big chunk of the breadth and depth of scheduling and placement constraint functionality of the scheduler all the way up into Deis. So right now, the Deis constructs here are things like tags. We may also want to allow for like a pass it raw to the scheduler type of model, where depending on the back end, you can just kind of, because the way Swarm models constraints and the way Mesos model constraints are wildly different. So getting something that is going to cover everything to allow for things like co-located placement is going to be very important. So I would say, yes, there are plans to support that. And I would say, yes, they are vague right now, because, until we get a better understanding of, where we're really headed, it's hard to kind of put all this stuff into focus. But assuming we're going to be going in the Kubernetes direction, I think that Kubernetes has the ability to do, the sort of affinity that is required to get colocation. Other questions? Yeah, so we have talked about pod style applications prior to this. One of the other things that's very of great interest is better sort of intra-cluster communication. So if you have multiple apps inside of a cluster, allowing for those apps to communicate amongst each other without necessarily having to traverse the internal routing mesh, and basically maximizing speed inside of the cluster. So trying to get a better story there is something we're actively looking at. But between everything we went over on the roadmap right now, there's quite a bit of work, and I think once we get a new default scheduler, things are going to become a lot more clear with regard to the roadmap. So anything that folks think is missing from the roadmap today? No? Okay, good. Either people are quiet or people realize we have a pretty long roadmap at this point. So great. Well, anything else from the Deis team or anything on our end that we want to share? No. All right. Well, wonderful. Thanks everyone for participating. We're going to be updating the roadmap shortly with the updates we discussed, and look forward to the v1.10 release, which should be a great one. So thanks again for attending, and we'll see you next month.
Thanks, guys.